Okay, so we looked at costs. So now it's a question. Now it's a question of putting those costs into the context of different market structures. The variety of them, and the first one that you'll have studied will have been perfect competition. Perfect competition. It's worth bearing in mind what's perfect about it. Yeah, and what the perfect refers to is the level of price competition. So we're not saying this is a great market structure. It's not perfect in many ways. Yeah, but it's perfectly price competitive. Yeah, which means that what that means is that consumers buy only on price. So when they're deciding whether or not to buy, the only thing that they're taking into account, is the price that the firm is setting. Yeah? And to do that, we need some assumptions. And the key assumptions of perfect competition are one, that as a consumer, you face identical products. Otherwise, you wouldn't buy just on the basis of price. Someone would see you might prefer one to another. Even if it was a bit more expensive. Secondly, we assume that you've got perfect knowledge. That firstly, you know that all the products are identical. And secondly, that you know what the prices are in the market, so you know whether you're being ripped off. Thirdly, we assume that you've got lots of choice. That it's convenient to buy one. That there's not. In other words, if you were faced with one that was a bit cheaper but a mile away, a kilometre away, then you might not. You might not buy the cheaper one. So we assume that there are many firms, many buyers, and many sellers. To avoid that idea that that actually there's only a limited choice. And finally, we assume that there are no barriers to entry in the long run. There are always barriers to entry in the short run because of the fixed factor of production. And what that means is that the market is contestable. So what does that leave us with? So we've got this idea that we've got identical products, perfect knowledge, many buyers and sellers, no barriers to entry and exit. What that means is that in the long term, the firm will be unable to make significant amounts of profits. And the reason for that is that if firms in a sector were making lots of profit, then new firms would break into that market to take those profits away from them. So in the long run, the firm can make only normal profit. And normal profit is defined as the minimum profit needed to keep the firm, keep factors of production in their current use. But so what are the implications for the model? Then what we can say is that, we're talking about a market here like, I don't know, kind of coffee growers in the Central African Republic or something. And the implication for the firm is that whatever the industry price is, it's going to have to accept it. Imagine that, you were being paid $1 a kilo for bags of coffee in the Central African Republic. And you then tried increasing your price to $1.10 or $1.05. It doesn't really matter. No one will buy from you because there are plenty of alternatives at exactly the same quality, but at a lower price. So therefore, what would happen is that your demand would fall to zero. At any price above $1, quantity is zero. So your demand kind of looks like that, but basically we draw it like that. And what that's showing you is that any increase in price above the current level causes demand to fall to zero. Demand is perfectly elastic or totally elastic. Price elasticity demand is equal to minus infinity. So what determines that dollar? The answer is it's determined by the interaction of industry supply and demand. So there's the global demand for coffee. That's the supply of all coffee growers. That determines that the global price of coffee is $1, and therefore, as an individual coffee grower, you have to also sell for $1. So let's have a think about what that means for the firm's output decision. Well, we're going to assume another assumption. It's not distinctive to perfect competition because we assume this in all market structures. The assumption is that the firm is going to want to maximise its profits, which is not an unreasonable assumption, just because profits are useful. Profits can be reinvested, profits can be paid to owners, in the form of dividends, and so on and so forth. So what we need to find is which output. We don't have any control over price in perfect competition, so which output will maximise profit? The guy can choose how many bags of coffee, how many hectares of land he wants to cultivate. So how should he decide? And this is where what we did yesterday and the day before comes in. because we can say, well, look, he will want to, he will only want to grow. He will only wants to grow coffee. He's thinking about growing an extra, 10 kilos of coffee. He only wants to do that, if it's profitable. So if it adds more to revenue, which is just the money that you get in, if it adds more to revenue, than it adds to cost. So we say, well, look, the guy's making $1 a bag, so we can say that his marginal revenue is $1. Every bag he sells, he gets an extra $1. It's plus $1 per bag. And of course, on average, he's also getting $1. So in perfect competition, marginal and average revenue are the same. So when he's deciding how many bags of coffee to make, what he's interested in is his marginal cost. And we said the marginal cost looks like that because initially we have increasing returns and then we have diminishing returns to the variable factor. So does he want to make the 10th bag of coffee? And the answer is yes, because he gets $1 for selling it, but it only costs him, say, 20 cents of fertilizer or labour and something like that. Does he want to make the 30th bag of coffee? Yeah, because the extra revenue is more than the extra cost, and so on, all the way to that one. So this guy's going to make all of the first 100 bags of coffee because these ones, they add more to revenue. Marginal revenue is greater than marginal cost. But he doesn't want to make anything past the 100th one because now the extra cost is above the extra revenue. And this is another graph where we're looking vertically. So above this point, MC is greater than MR, so you wouldn't want to make that many. So, okay, so what does that tell us? Let's have a think about, well, is the firm making a profit? So marginal cost is useful, but it's not completely useful. The trouble with marginal cost is it only tells you about the last unit of coffee. So if we say the 100th bag of coffee cost $1, well, fine, but what about the other 99? And in any case, it's only a type of variable cost. So therefore, to find profit, we know that profit is equal to total revenue minus total cost. Total revenue is price times quantity, and price is the firm's average revenue. Total cost is the cost per unit, the average total cost, times output. So if we go back to our original diagram, then we go MR equals AR there. We've got MC like that. What we know is that average cost, as long as marginal cost is below average cost goes down. As soon as marginal cost is above average cost goes up. So let's make a firm that's profitable. So what we can have is average cost drops below average revenue, like that. So the firm wants to maximise its profits, so it produces at MC equals MR, it produces, say, 100 bags of coffee. Its revenue is $100 then. $1 times 100. It's that square there. Its costs, though, are determined by the average cost, the average variable cost and average fixed cost of making 100 units. That is that number there. It's not the minimum point of the average cost curve. Average costs are slightly higher than that. So that's, say, 80 cents. So its costs are $80. Its revenue is $1,000. Therefore, it has abnormal profit. It has abnormal profit of this top box here, which is $20, which is the gap between revenue and cost. If we look at that same thing, on a total revenue and total cost diagram, in perfect competition, total revenue just goes like that, because each bag of coffee generates $1, so it goes $1, $2, $3, $4. We know that costs start there, because that's essentially the firm's fixed costs. And we also know that if we replicate the diagram that we just did, we also know that the firm can make a profit. So total cost must look like something like that. And our profit maximising output is something like that. Where that would be $100 and that would be $80. And that distance there is $20. Okay. So the last thing then is what happens to perfect competition. What happens to firms in perfect competition in the long run? What we said is that essentially firms will either enter or leave the market. depending on whether they're abnormal profits or not. So if we take the example that we just saw, here's the industry: demand, supply, price is $1. Here's the firm. So this is a single individual firm. And what we can see is that they're selling for $1. And in our original example, we said, let's suppose that the firm can make abnormal profits. And we had that as 80 cents and so on. So what's going to happen in the long run? The answer is that new firms will enter this market. And the way we show that is in the industry market, supply starts to increase. What that does is it pushes down price. Price is pushed down again as more firms enter. And they'll continue to enter until it's no longer possible to make this supernormal or abnormal profit. And that's going to happen when price has been pushed down to the lowest point of the average cost curve. Yeah? So actually price can be pushed down to about 70 cents. So supply continues to increase, S1, S2, S3, until the firm is only able to make normal profit. The firm's output has fallen from, say, 100 to 80 or something. And we have a new equilibrium at that point. So in the long run, in perfect competition, the firm ends up with, we end up with something that looks like this, where the firm is only just able to break even. And remember that the firm's costs include like an allowance for the entrepreneur's salary. So it's not really making no profits. That's why they're called normal profits. And so that's the long run for the firm. Or if you look at it on a total diagram, total revenue looks like that. Total cost, try and think that up. Total cost, it kind of starts like that. And then looks like that, So total revenue just equals total cost. Average revenue equals average cost. Right, let's stop there because I'm past my 10 minutes. I'll come back to do something on efficiency and stuff on another one.